You ever wonder how you could, actually speak the language of computers? And I'm not talking about Python or Java. No, no. I mean the real fundamental language underneath all of that. It's all about numbers. And today, we're going to get you fluent.
I mean, think about it. How does a machine that basically only has two fingers, a 0 and a 1, an off and an on, count all the way to 1,000,000 and beyond? It sounds kind of crazy, right? Well, that's the big puzzle we're going to solve together, and trust me, by the end of this, the light bulb is going to go on.
All right, so here's the game plan. We're going to start with why we even need different number systems. Then we'll look at our numbers versus the computers. We'll meet a couple of clever shorthands called Octal and Hex, learn the rules for translating between them all, see it in action, and then I'll leave you with a handy coder's cheat sheet. Okay, first up, to really get any of this, you've got to understand one single super important idea, and that's the concept of a base. Seriously, once you get this, everything else just clicks into place. So what is a base? It's just the number of unique digits you get to work with. Think about it. We humans have 10 fingers, right? So we naturally came up with a base 10 system. That's why we have 10 digits. 0, 1, 2, all the way up to 9. It's really that simple. Every number you've probably ever thought of uses this system. So that's our world, base 10. But what about the machine's world? Let's put them side by side and see how we can translate between the way we think and the way a computer thinks. And here it is, plain and simple. On the left, that's us, our language, decimal, with all 10 of our digits. But on the right, that's the computer's language, binary. It's only got 2 digits, a 0 and a 1, an off and an on. That's it. And get this, everything on your computer, your photos, your music, this very explainer, it's all just a ridiculously long string of those 2 little numbers. Okay, so if everything is just ones and zeros, you can imagine that trying to read that would be an absolute nightmare for us. This is where a couple of other systems, Octal and Hexadecimal, come to the rescue. Don't think of them as more stuff you have to learn. Think of them as incredibly clever translators that make our jobs way, way easier. Yeah, just look at that. That string of ones and zeros, that's not even a very big number, but it's already a total mess to read, isn't it? Now imagine trying to find one little mistake in a line of code with thousands of those. No way. We needed a better way for sure. And that's where Octal steps in. This is a base 8 system, which means it uses digits from 0 to 7. Now here's the magic trick. It takes that long, ugly binary string and groups the digits into nice, neat little sets of 3. All of a sudden, these huge numbers become much shorter and a lot easier for our human brains to handle. But then you have the real powerhouse, hexadecimal, or hex for short. This is base 16, so it uses our usual 0 through 9, but then it needs more digits, so it just uses the letters A through F. And the reason it's so powerful is because it groups binary bits into sets of 4. This makes it an even more compact shorthand. You see this stuff everywhere in programming, for things like color codes on websites or memory addresses. Okay, so we've met the different number systems. We know who the players are. Now, how do we actually learn the rules? How do we translate between them? Let's get into the how-to. So, let's start with the big one, how to turn our numbers into the computer's language, binary. It's actually a pretty simple process. You take your number and you just keep dividing it by 2. Each time you divide, you write down the remainder. It's either going to be a 0 or a 1. You keep doing that until you hit 0. Then, you take all those remainders you wrote down and just read them from the bottom up. That's it. That's your binary number. And going back the other way, from binary to our decimal system, is just as easy. See, every spot in a binary number has a value. It's a power of 2. Starting from the right, you have the ones place, then the twos place, the fours place, the eights place, and so on. All you do is multiply each digit, the 0 or the 1, by its place value, and then just add them all up. And just like that, you've translated from machine speak back into something we recognize. Now, here's a pro tip, probably the most important trick to remember. When you're converting between all these systems, think of binary as your central hub. It's like the main airport. If you want to go from hex to octal, the easiest way is to fly from hex to binary first and then take a connecting flight from binary to octal. It's the universal language that connects them all. And this is where that whole shorthand thing we talked about just becomes awesome. Check out how simple this is. You take some big, ugly binary number. You just split it into little chunks of 4 digits, starting from the right. Then you convert each tiny chunk into its one hexadecimal character. And that long, messy string of ones and zeros, it suddenly becomes just 2 letters. How cool is that? So much cleaner.
All right, theory is one thing, but let's put it all together and see a real example. We're going to take one single number and translate it across all 4 systems we've talked about. Let's see what it looks like.
And here we go. This really brings it all home. Let's take the number 219. In our everyday decimal system, it's just 219. For the computer, it becomes that long binary string, 110, 11011. But look, using our clever shorthands, we can write that exact same value as 333 in octal, or even more concisely as just dB in hexadecimal. 4 different languages, one single value. Okay, we have covered a lot. So to wrap things up, let's go over a quick little cheat sheet, some essential tips to help you get really good at this. Okay, here are the big takeaways. First, remember those groupings. 3 bits for octal, 4 bits for hex. That's your shortcut to everything. Second, always double-check your work by converting back. It's a simple sanity check. Third, if you can just memorize the first few powers of 2, 8, and 16, you'll be amazed at how fast you get. And finally, you know it. Practice, practice, practice. Just like learning Spanish or French, the more you use it, the more natural it becomes. So there you have it. You've just learned the fundamental language behind every single digital device in your life. It all starts with a simple 0 and 1, an on and an off. And from that, we build everything. So the only question left is, now that you know how to speak their language, what are you going to tell the machines to do?